This video is for 16.1's lesson. So if you have not already completed this Spark, then go ahead and do that and then come and see about some different ways I thought about this problem. So it says that Charisse is collecting data on the lengths of crocodiles for a science project. She thinks it would help to make a poster for her class so the students can understand her data at a glance. How do you think she should display her data? So I know that in Ed, it gave you one example and it showed it just like as a chart. And that's a great way to display it. So one thing I did notice is that we've got three different crocodiles. So I can't types of crocodiles. So I can't necessarily put them all on the same chart or graph. It's maybe not going to differentiate between them very well if I just put all of them. So since they're all three different, I'm thinking I've got to at least have three different things. So whether you have three different categories on your chart or three separate dot plots. So that is one way, right? So that in Ed, it just showed a chart. So it had the American crocodiles and then it listed the four in order. It had the Australian fresh crocodiles. It listed them in order. It also had the Orinoco, never seen that word in my life before, crocodiles, and those four. And it's important that they go, so, right? This is the alligator, this is their lengths. So it's important that we put these in order so that we can kind of see we're starting on the left, which in my video is this way. So we're starting on the left and then working our way over till we get to the end and the biggest one. So another way we could do it is to draw a bar chart for each type. We could do different types of graphs. So we could make a dot plot. So I could say these are my American crocodile lengths starting from 3 and then 3.5, 4, 4.5, and 5. So I've got one that's 5. I've got one that's 4.5, one that is 3, and another 4.5. So I can see it's pretty common to have a 4.5 American crocodile or even a bigger than that. So this one kind of is a little bit on the smaller side. So I like putting them in dot plots. It just helps organize it and helps me visually see what I have and if it's not fitting in with the rest of them. So then I couldn't just put these Australian freshwater crocodiles on the same chart because these are the American ones. I'd have to make a separate dot plot for the Australian freshwater crocodiles with its different measurements, right? I can also see how one really good way just came up with, well, I didn't come up with this idea. People have been using bar charts. So I could show like different ones, like I could do all of the, so, right, we're going up in increments of 0.5. I just feel like I have a really good idea. So here'd be 1, 2, 3, 4. I think 5 is our biggest. So I could do all of the American crocodiles in blue. So it went up 5, 4.5, 4.5, and 3. I mean, I probably should have gone the other way going up, but for some reason I started at 5, right? And then I could do the American freshwater or Australian freshwater crocodiles in a different color. So 2.5 was the biggest. Then I can really kind of compare. Oh, look, these ones are a lot bigger than this one is 2. This is another 2. And then this one went up 1.5. So I can see, yeah, the American ones are much bigger. And then I could do the Orinoco crocodiles in a separate color, so up to 4.5. So again, right, these ones go pretty high. So a couple of those and a 2.5 and another 2.5. So I can see the smallest ones are these freshwater ones as opposed to these, which are much larger. So just another way. So, right, just a table is great. People can read it, separate dot plots, or organizing with colors and things, showing them together so we can see and compare them side by side. So we're going to be talking about these data distributions today and how we can share that information with other people. And we're going to be classifying the shapes of them. So if you feel like you can describe the data distribution and different aspects about it, its peaks, its gaps, its clusters, what it looks like, then that. And if it's symmetrical or not, then that's a 3. So if you feel like you can identify their shape and the different attributes about it and understand what is that actually telling us, then that's a 4. If you feel like you can find peaks, gaps, and clusters, all 3 of those, then that is a 2. And if you can find some of those things, then that is a 1. So our goal here today, peaks, gaps, clusters, so we can do all of these and we can analyze its shape and decide, is it growing? Is it shrinking? Is it symmetrical? What's happening to this data? So data can be described by its shape. So when you hear the word cluster, what does that make you think of? If there's like a cluster of people over there and cluster of people over here. So clusters are groups. So a cluster is a group of data. So when the data is bunched up together, that is a group or a cluster. So when you hear peak, what do you think of? So I think of like a mountain peak that is the highest point. So that is the peak value is what appears the most. So some other words for that might be your mode or what's most common. The peak is the highest point of the data. What does a gap make you think of if there's a gap in there? So, right, if there's a gap in between the line of students, that means there's nobody in there. So on my data, that means there's nothing for that one. So if I'm asking how many students read or did homework last night and how many minutes it took them, and nobody said it took them 2 hours, but it took somebody 3 and it took somebody 30 minutes, then that would be a gap in my data. So a gap is just an interval, a section that has no data in it. So we're going to be using those words to help us describe this. So number 1 says seeing data represented as dot plots and histograms can help us find and understand different patterns. So we've been doing this. We're just giving it some different names, some more mathematical names now. Mr. Ortega surveyed one of his classes to determine the number of siblings each student has. So every dot is representing a student, and the number below represents how many siblings they have. So the results are summarized here. What conclusions can we draw about the distribution of the data? So first we want to know how many students did he survey? To do that, remember every dot is a student, so we're just counting up the dots, tells us how many total students there are. Now we're looking for a cluster of a group of data that is together. So I can see all of this here is grouped together, right? Then there's a space here. So this one is not into this cluster. So there is one cluster, one group, and it goes from 0 to 3. So this has one cluster from 0 to 3. Where are the gaps? Well, we have no data at 4. We have no data at 6. And we don't really have to list 8 as a gap, even though there's nothing there, because there's nothing past that point. So that's just no data is past that point. And then the peak, again, remember, is our highest point. So where do we go up the highest? It has one peak with the number 1. So we've got one cluster here. We've got 2 gaps at 4 and 6, and we have one peak at the 1. So you can see all of that different information displayed in your dot plot very easily. So now we're going to find the median here. So these numbers are in order for us already. So as I'm just going to use my dot plot and work through it, but I want to make sure I go up each column. So this 0, I'm going to use my red actually. So this 0 matches this 7. Then I'm going up and over. So 0 matches to 3, 0 matches to 3. So all my 3s are gone. 0 matches to 2. So I always like to start at the bottom and work my way up. So 0 matches to 2. So I've used all my zeros. So now 1 matches to 2. 1 to 2, 1 and 2, 1 and 2. So now I'm at 1 and 1. So I'm left with 1 is the median. So do you think does the median fit the overall pattern of data? So do you feel like 1 is a good representation of this data? So when you're thinking of does it represent it, right? If I have an opinion and I share that with somebody and they're going to go represent me to somebody else, I'm hoping that, right, they're going to take into account what did I actually say. So they're not going to go say their own idea. They're going to represent my idea. So does it represent this data? So I feel like, you can argue either way, yes or no. I would say yes, because the mode is also 1. Most of my data, most of the students have 1 sibling. That's the most amount that most people have. And it's pretty close to where this big cluster of data is. 1, it's only 1 away. Some people have 0, some people have 2, but that's still pretty close representation of that number. You could also argue no, like 1 is not close to 7. By putting in the 7, it's not really representing, or by saying it's only 1, that's not really representing the people that have larger families. So you can argue either way. You just need to justify and prove your answer. Okay, so our last one, we just want to decide which of these are true. So an equal number of students have 0 and 4. So 0 and 4, is that true? Are there the equal amounts of dots above that? The majority of students have 2 or fewer siblings, so 2 or less. So is that most of the dots in this section? So again, we're looking for 2 of these that are true. Only 2 of the students come from noticeably larger families. So, and again, that could be, relative. Maybe some people think that to be big, that's 3 people. But I would say, right, this is kind of where our cluster is. And then here's some larger families. Is that 2 students? Most students have 1 sibling. So the most students, well, so it's kind of hard to understand those sometimes. Most students have 1 sibling. That's the most common amount. But that doesn't necessarily mean that most of the students have 1 sibling. So you have to decide. Those can be kind of tricky to read there. More students have more than 4 siblings than 0 siblings. So students have more than 4 compared to 0. Is that true? So I only see 2 students here and I see 6 students here. The only gap in the data is between 3 and 5 siblings. So they said there's a gap here and there's only 1 gap. Is that true? And the modes of the data, so that's the ones that occur the most, are 0 and 2. So remember, mode is the peak. Which one's the highest? So we're looking for 2 of those that are true. Okay, so go ahead and, there it is, complete task 1 and come back when you are ready to do task 2. So task 2 has this fuel efficiency at Max's dealership of different vehicles. I can see 1 vehicle only gets 5 to 9 gallons. There are 2 vehicles between 10 and 14. Okay. So first, let's look at the peak. So our peak is the highest point. So the peak fuel efficiency says that there are 8 vehicles that have a fuel efficiency of 20 to 24. So the peak, the most common number is 20 to 24. Most of the vehicles have a gas range there. So now let's just look at this shape of the data. So right, it kind of goes up and then it goes down. So overall it increases. So right, the higher the gas mileage, it goes up. So more cars have that. Then it reaches a certain point and then fewer cars have these higher miles per gallon. So luckily there's not very many cars that are very terrible. And then there's lots kind of in the middle range. And then as they get really efficient, it kind of tapers off again. So it's kind of goes increase, decrease. Now, is this symmetrical? So when something is symmetrical, that means that I can perfectly cut it in half and I can fold it over that line and it's going to match each other. So I could draw this heart here and I can cut it in half and fold that over each other. It has one line of symmetry. This oval shape here, I could also cut it horizontally and I could fold it up and down as well. This heart though, right, that point doesn't match up to there. So this has multiple points of symmetry. This only has one. So if we look at this graph here, right, and cut it down the middle, would it fold on top of itself? So I notice here, right, this line and this line are not the same. This one's a little higher than this one. These two are symmetrical. The red would fold on top of each other, but the rest of these colors are not folding perfectly onto each other. So, right, so most of us, right, our hands are really good. They're symmetrical. They're open, they close. So mine are almost symmetrical, right? So I don't know if you've ever noticed, mine are not lining up with each other. Close, not quite. So symmetrical, right, folds and is exactly the same. And so I just want to do one other little thinking right here. Let's take a second and make a dot plot here. So we're going to count by 5 since all of the numbers end in 5s and 0s. So my lowest is 10 and it looks like it goes up to 90. So I don't even need to start at 5. I'm going to start at 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, and 90. So we're going to put all of these onto this dot plot. So I'm going to start with these at the top. So we've got 50 and 30. So here's 50 and 30. 30, 60, 60. So I've got 30, 60, 60, 60, 50, 50, 60, 50, 50, 45, 60, 60, 60, 30, 45. So 60, 30, 45, 25, that's a new one, 25, another 60, and all the way to 90, 90, 10, and 60, 90, 10, and 60, and 55, down here, 45, here, and 30. So these are 25 sixth graders were surveyed how long it takes them to get ready in the morning. So we can see here we have this information. So our peak, the highest, the most common amount of time is 60 minutes or 1 hour. We have a couple clusters here. So right, there's a group here between 25 to 30 minutes. We also have another cluster here between 45 to 60 minutes. So groups, right? Those clusters are just grouped together. You can have more than one cluster. And we've got gaps between 10 and 20, or so I guess it would be 10 to 25. We've got another gap here and a really large gap here. So on our data is not going to fold in half and be symmetrical. So we can see, right, most students are taking about 45 to 60 minutes to get ready for their day. The most common is 60. Nobody spent 35 or 40 minutes. So lots of questions can be answered easily with these dot plots. Okay, so go ahead and finish your tasks for today and do your check for understanding. If you have any other questions about peaks, gaps, and clusters, be sure to let me know. And let's set up a time to meet together and practice that more.